Hello friends, welcome to engineering tutorial. So here we are with another question on superposition theorem involving dependent sources. So this is the circuit here with all the circuit elements involved. So here this is what makes this circuit very interesting and very important, this dependent source. So it is a current source which is dependent on a voltage across this resistor, this 2 ohm resistor. So this is a voltage dependent current source. So this parameter, voltage drop across this 2 ohm resistor, becomes important. Okay. Now, so it has been asked in this question to find out Vx, then the power across means supplied or absorbed by the 5 ampere independent current source, the 6 volt voltage source independent, and across this dependent current source, this. So in order to do all of this, first we have to determine Vx. Okay, so let us do it. So now we will find out Vx using superposition theorem. So for that we have to consider each of the independent sources one at a time. So in step 1 we will consider the 5 ampere independent current source and deactivate this 6 volt independent voltage source. So how to deactivate it? We simply replace it by a short circuit. Okay, we replaced it by a short circuit. Okay, here the voltage is Vx dash let. Okay, step 1, this is Vx dash by 2, like we did in all the previous questions. So this is step 1, let this voltage drop across 2 ohm be Vx dash by 2. This is shorted, these 2 points, so here also it will be Vx dash. Okay, no drop, so these 2 points will have the same potential. Now we will apply nodal analysis here. Let this current direction be like this, here also like this, it is in this direction, it is going towards. So 5 ampere is going towards this node and all the other currents are going outwards away from the node. So the nodal equation will be 5 is equal to Vx dash by 2. Vx dash by 2 means Vx dash minus 0 by 2. This is connected to ground. Okay, it means this Vx dash minus ground by 2. Nodal analysis simply means Vh higher potential minus lower potential, resistance involved. I have already discussed about these things, how to put nodal analysis, mesh analysis and all the other circuit analysis techniques. You please watch those videos. Okay, so Vx dash by 2, then plus Vx dash by 4 and this current which is Vx dash by 2, this dependent current source. So that implies 5 is equal to Vx dash plus Vx dash plus 2 Vx dash. This is equal to simply 5 Vx dash by 4. That implies Vx dash is equal to 5 into 4 by 5. 5 is cancelled, which is 4 volt. Vx dash, this voltage in step 1, considering the current source, the independent current source 5 ampere, deactivating the 6 volt voltage source, is 4 volt. This is the conclusion of the first step. Now in the next step we will deactivate this current source, that means open circuit it, consider or reconnect the 6 volt voltage source, and then again determine this voltage. Okay, so let us do that. So in step 2 we will consider this 6 volt voltage source, neglect or deactivate the 5 ampere current source. So how to deactivate it? Simply replace the current source with an open circuit and will reconnect this voltage source. 6 volt. Okay, here this drop will be Vx double dash because it is step 2, it will be different. We are considering the 6 volt voltage source, neglecting this current source. This will become Vx double dash by 2. Now again we have to put nodal analysis. Here also it will be Vx double dash, and let us say the voltage at this point B, we assume Vp. Now there is something interesting here. This 2 points Vx double dash and this Vp, these two nodes, okay, these two nodes, they have this voltage source in between. So this becomes a super node. We combine it to form one node, which is super node. I have already discussed about super node, that is two nodes having a voltage source in between behave as a super node. These two nodes Vx double dash and Vp, they have a voltage source in between, so it acts as a super node. So I would request you to please watch the super node video that I have posted. Okay, so for the super node, an auxiliary equation which relates the potential between these two nodes becomes very important. So here the auxiliary equation is Vx double dash plus 6 minus Vp is equal to 0. We put the KVL from this point to this point, that is Vx double dash, okay, (6 volt) Vp. We put the KVL in this way. So the KVL equation is this: Vx double dash plus 6 volt minus Vp is equal to 0. Okay, so this is the important equation. Vx double dash plus 6 minus Vp is equal to 0. Let us write it here because we require this space to solve the nodal equation. 6 minus Vp is equal to 0. This is the first equation. Okay, now let us assume the current directions as per our choice. Let us be outward going current, this also outward going current. So this is a super node. So the nodal equation for this super node will be Vx double dash by 2, okay, this current, plus Vp by 4, okay, this is also outward going current, plus Vx double dash by 2 is equal to 0. KCL equation for this super node. Now in place of Vp we will substitute this equation. Vp can be written as Vx double dash plus 6, okay, Vp can be written as Vx double dash plus 6. So we will substitute here Vx double dash by 2 plus Vx double dash plus 6 by 4 plus Vx double dash by 2 equal to 0. Okay, that implies if we consider it totally, we take LCM 4, 2 Vx double dash plus Vx double dash plus 6 plus 2 Vx double dash is equal to 0. That implies 5 Vx double dash plus 6 is equal to 0. Okay, that implies Vx double dash is equal to minus 6 by 5 volt, okay, which is equal to minus 1.2 volt. Yes, 510 5 minus 6, yes, minus 1.2 volt. Vx double dash is equal to minus 1.2 volt. This is this voltage, okay, the voltage drop across 2 ohm for step 2 considering 6 volt deactivating the 5 ampere current source. Okay, now we have to find out the Vx, the net effect of both these independent sources combined, that is 6 volt and 5 ampere. Okay, okay, so we got these two values of this voltage drop across 2 ohm resistor for the first and second step considering each of these independent sources separately. So the net voltage drop, the combined effect of both these independent sources is the sum of the individual voltage drops, which is simply Vx dash plus Vx double dash. This is the superposition theorem principle, which is 4 minus 1.2 volt, which is equal to 2.8 volt. Okay, so we have got Vx, okay, Vx is equal to 2.8 volt. We have got Vx is equal to 2.8 volt. Now it has been asked to find out the power supplied or absorbed by the 5 ampere independent current source. Now see, here Vx is the voltage drop across 2 ohm resistor. So it means the voltage here at this point is Vx. It also means that the potential across this 5 ampere independent current source is also equal to Vx. Okay, voltage here is Vx, between this point and ground is Vx, means the voltage across this current source is also Vx, which is equal to 2.8 volt. Current is moving in this direction, 5 ampere. Voltage is 2.8 volt. Current when flows from positive to negative terminal, externally, it means it is supplying power. It is positive. So the power here is P5A is equal to voltage into current, which is equal to 2.8 into 5, which is equal to how much? 2.8 into 5, which is 5, 10, 40, 14 watts. 14 watts. Okay. Okay. Now 5 ampere is done. Next is this, the power supplied or absorbed by the 6 volt. This is 14 watts. By this 6 volt, this voltage source. Now here we have this 2 ohm resistor, here there is 5 ohm, here it is Vx, which is 2.8 volt. So the current here will be, how much current will flow? I will be equal to 2.8 by 2, which is equal to 1.4 ampere. 1.4 ampere. Here 1.4 ampere is going. So how much current will flow here? 5 minus 1.4, which is equal to 3.6 ampere. 3.6 ampere. Okay. So here 3.6 ampere is flowing. It is flowing outwards, away from the positive terminal towards the negative terminal. It means the 6 volt is also supplying power. So this power by the 6 volt is equal to voltage into current, 6 into 3.6, which is equal to 6 into 6, 36, okay, 6 12, 18, 21.6 watts. Okay, 21.6 watts. So P 6 volt, 0.6 watts. Next is this power supplied or absorbed by the dependent source, dependent current source. So here this is Vx by 2. Okay. So here let us say we have a potential, let's say Vp. Okay, we have to determine this potential. So the auxiliary equation, we know that Vx plus 6 minus Vp is equal to 0. Vx we have calculated as 2.8 plus 6 minus Vp is equal to 0. So Vp is equal to 8.8 volt. Vp is 8.8 volt. It means Vp is 8.8 volt. Let us write it down here. It means that this the voltage across this is equal to 8.8 volt. The current flowing is Vx by 2, which is equal to, Vx is 2.8 by 2, which means 1.4 ampere. 1.4 ampere. Now, if you see, this current is flowing in this way. Away externally from the negative towards the positive. I have always told you that when current flows through any circuit element from positive to negative, okay, any circuit element, when current flows from positive to negative internally, it means that this circuit element is absorbing power. Absorbing power. Power absorbed is always negative. It is always written in a negative way. So here the power of absorbed by this element we can write in negative way as minus V into I, which is equal to minus 8.8 into 1.4. Okay, so let us calculate it. 8.8 into 1.4 is equal to, okay, 32, 35, 882, 13, okay, minus 12.32 watts. Okay, so this power by this dependent source is equal to minus 12.32 watts. Okay, so here we have calculated all the parameters that were asked. The dependent, this voltage drop across this 2 ohm resistor, this value of this dependent current source, then the power supplied or absorbed, but in this case is the independent sources, it was all supplied. In this dependent source it was absorbed. Okay, so we have calculated everything. Okay, so I hope you like this video, and please subscribe my channel for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.